Could we create a new law of physics? That question sounds a little strange. It sounds like asking if we could write a new rule for gravity. Like, we could all vote and decide that from now on things fall up. The universe doesn't seem to work that way. It does what it does. We're just living in it. We don't get to set the terms. And that's true, in a way. We can't just invent a rule and expect reality to follow it. The universe is the boss. Its rules were here long before we were. They will be here long after we are gone. They govern the swirl of a galaxy and the fizz of a soda can. They are not our laws. We can't amend them. We can't repeal them. But the question is more interesting than it first appears. It depends on what you mean by create. If you mean invent something from pure imagination, then no. That's not how it works. But if you mean discover something so new, so fundamental, that it changes our entire understanding of reality. Let's talk about what a law of physics really is. It's not a command, it's a description. It's a human-made summary of how a piece of the universe seems to behave every single time we check. Think of it like drawing a map. The land is already there, the mountains, the rivers, the coastlines exist whether you have a map or not. A map maker doesn't create the land. A map maker studies the land and creates a representation of it. The first maps were probably terrible. They got the big shapes wrong. They missed entire continents. But over time, with better tools and more exploration, the maps got better. They became more accurate. They became more useful. A law of physics is like a really good map of a piece of reality. Before Isaac Newton, gravity was just a thing that happened. An apple fell from a tree. The moon stayed in the sky. People knew these things. They didn't know why. They didn't know there was a single, simple rule connecting them. Newton didn't invent gravity. He was the map maker. He watched the apple and he studied the moon. He realized the same force was at work in both places. He saw a pattern, and he described that pattern with math. He created the law of universal gravitation. It was a stunningly good map. It was so good we could use it to predict the tides. We could use it to discover a new planet, Neptune, just by noticing that Uranus was wobbling in a way his law didn't quite predict. His map was so good. It showed us where to look for land we hadn't even seen yet. So in that sense, Newton created a new law of physics. He didn't make the universe obey a new rule. He gave humanity a new description of an old rule, a description so powerful it changed the world. For a couple of hundred years, we thought Newton's map was perfect. It seemed to describe everything about motion and gravity. It was the law. But then we started building better tools. We started looking more closely at the edges of the map. And we saw things that didn't quite fit. The orbit of Mercury was a little weird. It wobbled in a way that Newton's law couldn't fully explain. It was a tiny error, but it was there. It was a little smudge on our otherwise perfect map. Also, light seemed to behave strangely. A guy named Albert Einstein spent a lot of time thinking about light. He realized that Newton's map of gravity didn't work at all for light, or for things moving very, very fast. The map was wrong in these extreme places, so Einstein had to draw a new map, a better one. He created a new law of physics called general relativity. This new law described gravity not as a force pulling things together, but as a curvature in space and time itself. It was a wild idea. It said that massive objects, like the sun, literally bend the fabric of reality around them, and planets are just rolling along those curves. His new law explained the weird wobble in Mercury's orbit perfectly. It also made a bunch of new predictions. It predicted that starlight would bend as it passed the sun. People checked during a solar eclipse. It did. It predicted that time itself would run slower in a stronger gravitational field. We've checked this with atomic clocks. It does. Einstein's map was better. It covered more territory. It was more accurate. Did he create a new law? Absolutely. He replaced Newton's law with a deeper, more fundamental one. Newton's law isn't wrong now. It's just an approximation. It's a good map for everyday speeds and everyday gravity. But if you want to understand a black hole or a GPS satellite, you need Einstein's map. This process has happened over and over. We discover a set of rules, we call them laws. Then we find a place where those rules break down, and we have to dig deeper to find the new, better rule. We create a new law that explains the old one as a special case. The same story unfolded in the world of the very small. For a long time, we thought the world was made of tiny, indivisible balls called atoms. We developed laws for how gases behave based on this idea. Then we discovered that atoms weren't indivisible at all. They had parts of nucleus with protons and neutrons, and electrons zipping around it. So we needed new laws. The laws of classical mechanics, Newton's laws, just didn't work down there. Electrons didn't behave like tiny planets orbiting a tiny sun. They behaved in ways that were completely bizarre. They could be in multiple places at once. They could disappear in one place and reappear in another without traveling in between. This led to the creation of a whole new set of laws, the laws of quantum mechanics. These laws are maybe the most successful and strangest descriptions of reality we have ever come up with. They are all about probabilities and uncertainties. They say that at the most fundamental level, the universe is fuzzy. It's not a machine of perfect little billiard balls, it's a shimmering, uncertain dance of possibilities. The people who developed these laws, Planck, Bohr, Heisenberg, Schrödinger, and many others, were creating new laws of physics. They were mapping a continent that no one had ever seen before, a continent that defied all common sense. But the map worked. It led to the laser, the transistor, the computer, the nuclear bomb. Our entire modern world is built on this strange map of the quantum realm. So, can we create a new law of physics? Yes, and we are trying to do it right now. Because even with Einstein's map of the very big and the quantum map of the very small, our atlas of the universe is still incomplete. In fact, it has some huge glaring holes in it. The two best maps we have, general relativity and quantum mechanics, don't work together. They are written in different languages. They describe the same universe, but when you try to use them in the same place, like inside a black hole or at the very beginning of the Big Bang, they give you nonsense. They break. This is the biggest problem in physics today. We need a new map, we need a new law. A law that can unite gravity with the quantum world. A theory of everything. People are working on it. You may have heard of some of the attempts, like string theory or loop quantum gravity. These are not yet laws. They are candidate maps. They are mathematical ideas about what a deeper law might look like. They make predictions, but we haven't been able to test most of them yet. The person who figures this out, who writes down the single framework that describes both a star and an electron, will be the next Newton or Einstein. They will have created a new fundamental law of physics. That's not the only place we're looking for a new law. There are other giant mysteries. When we look out at the universe, we see that it's not just made of the stuff we know, atoms, light, all the things in our standard model of particle physics. Most of the universe is missing. Galaxies are spinning way too fast. Based on the stars and gas we can see, they should fly apart. There must be some other stuff there, some invisible mass whose gravity is holding them together. We call it dark matter. We know it's there because we can see its gravitational effects. We can map it, but we have no idea what it is. It's not any kind of particle we've ever discovered. Finding out what dark matter is will almost certainly involve a new law of physics, or at least a major new addition to our current laws. It might be a whole new family of particles with their own rules, and it gets even weirder. Not only is the universe expanding, but the expansion is speeding up, it's accelerating. Something is pushing everything apart. It's like a kind of anti-gravity that works over vast cosmic distances. We call this force dark energy, and it makes up most of the energy in the entire universe. We have a name for it, but we have almost no clue what it is. It could be a property of empty space itself. It could be some new kind of energy field. Explaining it will require a new law of physics. It's a really big one. So the job of creating new laws is far from over. Physics is not a finished book. We've written some amazing chapters, but we've just realized the book is much longer than we thought, and most of it is written in a language we don't understand yet. But there's another, more subtle way to think about creating a law. So far we've talked about discovering the pre-existing rules of the universe, but can we create a situation and an environment that behaves according to a new set of rules that don't exist in nature? Can we engineer a new kind of physics? The answer, surprisingly, is kind of yes. Consider something called a metamaterial. This is a material that is engineered in a lab. It's not about the substance it's made of, like plastic or metal. It's about its structure. Scientists design tiny, intricate structures smaller than the wavelength of light and arrange them in a repeating pattern. By doing this, they can make the material interact with light or sound or other waves in ways that no natural material can. For example, they can create a material with a negative refractive index. In every natural material, like water or glass, light bends in a certain direction when it enters. That's why a straw in a glass of water looks bent. A material with a negative refractive index would bend the light in the completely opposite direction. This is not a property you can just dig out of the ground. It's a property that emerges from the tiny artificial structure we built. These materials can be used to create things like invisibility cloaks. Not the magical kind, but devices that can steer light waves around an object as if it weren't there. When you're working with these materials, you are using the fundamental laws of electromagnetism, the same laws that have always existed. But the effective laws that describe how light moves through this specific human-made material are new. We have created a little pocket of the universe where a new, emergent, physical rule applies. We wrote the rule not with a pen, but by building a structure. We are doing something similar with quantum computers. A quantum computer isn't just a faster version of the computer on your desk. It works on completely different principles. It uses the weird laws of quantum mechanics, things like superposition, a particle being in many states at once, and entanglement, two particles linked in a way that what happens to one instantly affects the other, no matter how far apart they are. By arranging quantum bits, or qubits, in a very specific way and protecting them from the outside world, we are creating a system that follows a new set of computational laws. These laws emerge from the underlying quantum physics, but they only exist in the context of the machine we have built. We are coaxing reality into performing a kind of computation it would never do on its own. We are creating a system with its own unique physics, designed for a purpose. You could even argue that life itself is an example of this. The basic laws of physics and chemistry are the same inside a living cell as they are in a rock. But in a cell, those components are organized in an incredibly complex way. That organization gives rise to new emergent principles. Principles like metabolism, replication, and evolution by natural selection. Natural selection is a powerful rule that governs the development of all life. It's not a fundamental law of physics in the same way that gravity is, but it's a higher level law that emerged from the fundamental laws in the specific context of self-replicating chemical systems. In a way, the universe, through life, created a new set of rules for itself. So we have these different levels of creating a law. There's the discovery of a fundamental law, like gravity. There's the creation of an emergent law by engineering a complex system, like a metamaterial. What about the most sci-fi version of the question? Could we literally change a fundamental law? Could we reach into the code of the universe and change the value of a constant? Could we make gravity a little weaker, or the speed of light a little slower? Right now, that is purely a fantasy. We have no idea how we would even begin to do that. It's like being a character in a video game and trying to change the game's source code from within the game. The laws of physics seem to be the framework we exist in. We don't seem to have any access to the controls. Some theories, like string theory, suggest that the fundamental constants we see might not be the only possible ones. They might just be the values that our particular corner of the universe settled into after the Big Bang. This opens up the possibility of a multiverse, a collection of different universes, each with its own laws of physics. In some other universe, gravity might be stronger, electrons might be heavier, and life as we know it would be impossible. If that's true, then, our laws are not absolute. They are more like local bylaws. But even if there are other universes with different laws, it doesn't mean we can change the laws on our own. We're still stuck with the ones we have. The idea of changing them remains far outside of science and firmly in the realm of speculation. To change a law of physics would require a mastery of reality that is, for now, godlike. So where does that leave us? The question, could we create a new law of physics, has a few answers. If you mean, can we snap our fingers and make the universe different? The answer is no. We are products of the universe's laws, not their masters. But if you mean, can we make new discoveries that completely rewrite our understanding of the universe? The answer is an absolute, resounding yes. It is the entire goal of fundamental physics. We are searching for new laws right now in the mysteries of dark matter, dark energy, and the quantum nature of gravity. The next great law of physics is out there waiting to be found, waiting for a new mapmaker to draw it for the rest of us. And if you mean, can we use our knowledge of the existing laws to build new systems and materials that behave according to new emergent rules? The answer is also yes. We are just beginning to learn how to do this. We are becoming designers of reality on a small scale, creating little pockets where new physics can happen. The story of physics is a story of humility. Every time we think we have the final answer, the final map, the universe shows us something new and proves us wrong. It shows us that our map is incomplete. It forces us to explore further. And in that exploration, in that act of drawing a new, better map, we create a new law of physics. We create a new way for humanity to see the world. It's one of the greatest things we do.